Modern warfare is no longer dominated by massive fleets of fighter jets and aircraft carriers alone. The battlefield is being reshaped by autonomy, artificial intelligence, and swarming technologies. And at the center of this revolution is a groundbreaking idea developed by DARPA, the United States Defense Advanced Research Projects Agency. The project is called Gremlins, a swarm of reusable, air-launched drones that can be deployed in large numbers, complete missions, and return to a mothership in mid-air. This technology represents a radical leap forward in air combat, surveillance, electronic warfare, and strike capabilities, while dramatically cutting costs and risking fewer human lives. Over the next half hour, we'll explore how Gremlins work, why DARPA built them, how they are deployed, and the massive implications they carry for the future of aerial warfare. Traditional air power is extremely expensive and risky. Sending a fighter jet into contested airspace can cost tens of millions of dollars, and losing one can cause political uproar, international tension, and death. Even drones like the MQ-9 Reaper cost up to $30 million each, making them too valuable to lose in large numbers. The Pentagon needed something cheaper, smarter, and more flexible. A platform that could flood the skies, act independently or in coordination, and be recovered rather than destroyed. The answer was the Gremlins concept. Small, reusable drones launched from aircraft that can operate in dangerous zones, complete missions, and be captured in mid-air instead of landing on runways. DARPA envisioned a system where dozens of these drones could be deployed at once, acting as a force multiplier while keeping highly trained pilots and billion-dollar jets far from enemy fire. Each Gremlin drone is about the size of a small cruise missile and weighs around 700 pounds. Despite its compact size, it is loaded with advanced avionics, sensors, communications gear, and AI-assisted software. The wings fold during launch and deploy in flight, allowing it to be carried in large numbers by a single aircraft. The drones can be equipped for surveillance, electronic jamming, decoys, or precision strikes depending on the mission. Once released into hostile airspace, they communicate with each other and the launch aircraft through encrypted data links. They can fly in formation, collect intelligence, confuse enemy radar, or overwhelm defenses. Unlike kamikaze drones, Gremlins aren't disposable. Their value lies in their ability to do the job and return home. One of the most impressive aspects of the Gremlin program is how they are launched. Rather than taking off from runways like traditional drones, they are carried into the air by larger aircraft such as the C-130 Hercules. Once the mothership reaches mission altitude, the Gremlins are released in quick succession. Within seconds, they unfold their wings, power their engines, and begin operating autonomously. From that moment on, the host aircraft can retreat to safety, while the drones continue toward high-risk areas. The benefit is enormous. Instead of risking a fighter jet or surveillance aircraft in defended airspace, the Air Force can send dozens of Gremlins to probe defenses, gather targeting data, or deliver payloads, all without risking pilots or expensive platforms. What makes Gremlins truly unique is not just how they are launched, but how they return. After completing their mission, the drones don't land on runways. Instead, they rendezvous with the same C-130 that launched them and are captured in mid-air using an extendable recovery arm. The Gremlin approaches the aircraft autonomously with precision positioning using LiDAR, GPS, and optical sensors. Once aligned, a mechanical docking system secures the drone and pulls it into the cargo bay. The goal is to recover up to 4 Gremlins in less than 30 minutes, refuel them, perform quick maintenance, rearm them if necessary, and launch them again. This reduces downtime and eliminates the need for ground bases near the battlefield. Gremlins aren't just remote-controlled vehicles, they operate as a coordinated swarm. Built with AI-assisted decision systems, they can communicate with each other, assign roles autonomously, and adapt mid-mission. If a drone is destroyed, others can take its role. If communications are jammed, the swarm can continue operations with pre-built logic. In offensive roles, dozens of Gremlins might overwhelm an enemy's radars and interceptors by saturating defenses with false signatures and real threats. In reconnaissance missions, they can fly in different patterns, merging data from multiple angles. AI also enables formation flying, collision avoidance, and power management. The swarm becomes a thinking network in the sky, one that can't be stopped by disabling a single node. The Gremlins are not just an American experiment. They are signaling a new direction in air warfare. Other countries like China, Russia, and Turkey are watching closely. The idea of a recoverable swarm launched from the air breaks the traditional rules of drone deployment. China has already developed carrier-based swarm drones and AI drone boats. Russia has invested in loitering munitions and reusable strike drones. But the Gremlin's mid-air launch and recovery method gives the U.S. a significant lead in deployment flexibility and endurance. If successful, this concept could change how future air forces build fleets, shifting away from fewer high-value jets to many autonomous, semi-expendable platforms. DARPA's goal is to hand off the Gremlin's technology to the Air Force and U.S. Special Operations Command for full deployment. Future Gremlin variants may carry small missiles, electronic warfare pods, or reconnaissance packages. Their launch platforms could expand from C-130s to stealth transports, bombers, and even naval vessels. Advances in AI will allow swarms to operate without continuous human commands. Combined with hypersonic weapons, satellite networks, and combat cloud systems, Gremlins may become one of the most flexible and powerful tools in the Pentagon's arsenal. The age of the manned-only Air Force is fading, and a network of autonomous swarms may soon dominate the skies. DARPA's Gremlin drone swarms represent one of the most disruptive leaps in military aviation since the advent of stealth technology. They reduce battlefield risk, lower costs, expand mission capability, and transform how air power is projected. Instead of one $100 million jet entering enemy airspace, the U.S. could send 50 autonomous Gremlins to scout, jam, strike, or deceive. They are fast, adaptable, and, most importantly, recoverable, making them a true flying army of the future. As warfare evolves, swarms like these may determine the outcomes of conflicts before a single pilot takes off. If you enjoyed this deep dive into DARPA's Gremlins and the future of drone warfare, make sure to subscribe for more long-form defense documentaries. Drop a comment telling us which breakthrough military technology you want next. Hypersonic fighters, AI submarines, or orbital combat platforms. Like, share, and hit the bell icon so you don't miss the next episode. The future of warfare is arriving fast, and it flies in swarms.